Morning students, today we are going to see on basic laws in circuit theory. After completing this course, you can be able to apply those basic laws to the given circuit and you can be able to analyze the given DC network. The first law for this circuit theory is Kirchhoff current law, that is based on the charge. The current will flow across a closed path. If the path is break, the current will not flow. So that is in a closed path, the sum of the current is 0. We want to know what is a node. Node means that is a junction between two branches. If the two branches connected in a single point, it is called the node. Sum of current at a single node is equal to 0. That is current towards the node equal to away from the node. Next, you want to go know what is a voltage law, Kirchhoff voltage law. Voltage means that's a energy, potential difference. That is, energy can't be created nor be destroyed. It can be transformed to one form to another. That is, energy drop across from the source is occurs means the voltage rise will occur at the elements, reactive elements or resistive elements. That is, across a closed path, the voltage will be 0. Net voltage across the closed circuit is always be 0. There is voltage drop equal to voltage gain, that is voltage rise. For the given circuit, I have shown it is as. Next we are going to take it as Ohm's law. Ohm's law means if the current is closed in a circuit, it offers some resistance. That is, the Ohm's law is V is equal to IR. The resistance offered by the is called resistor. The resistance depends on the area of cross section and the resistivity and the length of the current carrying element. Next, you want to know what is a parallel network. That if the resistor is in parallel condition, that is, current is divided across those two resistors, then the network is called the parallel network. The resistors are in parallel condition. The equivalent resistance can be derived from those parallel resistance. The equivalent resistance can be 1 by R equivalent equal to 1 by R1 plus reciprocal of sum of reciprocal of those individual resistance. Then we want to know what's the current across each resistor. Across a parallel network, the current across each resistive element is different. In a series network, the current will be same across each resistance element. Similarly, the current can be determined for the parallel resistor by means of current division rule. That is, current across some nth resistor means total current into 1 by that nth resistor divided by 1 by total resistance. That is, total resistance means equivalent resistance. Next is the series network. The voltage across series network is always be different. The net equivalent resistance can be determined by addition of sum of those all resistances. Voltage across, you want to find voltage across some nth resistance means total voltage into that nth resistor divided by sum of those all resistors, series resistors. Next, you want to go analyze voltage and current across DC network by applying those three laws what you have studied before. The first one is the nodal voltage analysis. It is based on Ohm's law and Kirchhoff current law. Ohm's law is based on expressing branch current in terms of voltage and resistance using Ohm's law. We already said what is the node. So we want to node means by means of Kirchhoff current law across the node the sum of the current will be always 0. So we want to know the current, that is V1, that is Vx, current at the node Vx, the current at the node X, that is V1 minus what are the branching currents you want to analyze, that is V1 minus Vx divided by that reactive elements R1 plus V2 minus Vx divided by R2 plus V3 minus Vx divided by R3 equal to 0. Here we consider it as all the currents are towards the node. So in the other side of the equation, we consider there will be no outwards current. Consider the example. We have given the some DC network. 4 ampere current is flowing as the source to the network. We have two nodes, V1 and V2. We want to analyze the network. So they give the direction of one direction of current towards the node V1. That is the first node. So take it as towards the current equal to away from the current. So 4 amps equal to V1 divided by the reference node voltage will be always 0. So V1 by 3 plus V1 minus V2 divided by 1 ohm. From that we get the equation as 4V1 minus 3V2 equal to 12. And this is similarly applying KVL across V2. That is V1 minus V2 divided by 1 ohm equal to V2 divided by 2 ohm. V1 minus V2 is away from the node. V2 by 2, that is V1 minus V2 means current flowing away from the node V2 and equal to V2 divided by 2 ohm plus V2 divided by 1 plus 1. These two resistors are in series. So we get the equation as V1 equal to 2V2. And solving these two equations we get V1 and V2 voltages 4.8 and 2.4 volt. Next one is a mesh current analysis. Mesh means a loop. We want to analyze the loop current. That is indirectly we are going to analyze the branch voltages. That means of Ohm's law and Kirchhoff voltage law. The loop means that is a closed path. We want to analyze the loop current I1 and I2. We get the based on the Kirchhoff voltage law we get the loop equations, and solving those equations we get the mesh current. From that we get the voltage across certain load. So in the same way we analyze the for the given circuit we are analyzing the load current. Next one is the superposition principle. Superposition is nothing but if you drop the stone in a lake at position A and the position B at different times, we get the some response. Now we are going to drop the stone at same time, we get the sum of individual response. This is same as the superposition principle. That is, A is the input source and given to the system, we get the A as output. Similarly, B is the input and given to the same system, we get the B as output. And on giving those sum of those A plus B, we get the sum of those outputs. So similarly, if we have two sources, we want to have the single source at a time and masking the other source. If there is current source, we want to mask the current source by open circuited the source. If there is voltage source, 2 or more voltage source, we want to short circuit the source. That is open circuiting and short circuiting. This is a superposition principle. We have, for example, in a superposition, we want to apply the superposition principle to the given network. That is, we have two sources, VS1 and VS2. That VS1 is to be masked at first time, and VS2 to be masked at second time. That is, masking means short circuiting the voltage source. If there is a current source, you want to open circuit the current source. Finally, we get the R1 by applying mesh analysis or current division rule or Kirchhoff voltage law. This is the application, suggested strategy, voltage rule and Ohm's law. This is second example. Thank you.